Before we begin graphing sine and cosine transformations, we want to identify the key pieces of information to help us get an accurate graph. First of all, our a value. That is what we are multiplying by the function, and it gives us our amplitude. If the a value were negative, we would take the absolute value to get the amplitude. Our a value is positive, so it is the same as our amplitude. That acts as a vertical stretch. Next, we're going to identify our b value. That is what we're multiplying by the x. That is a horizontal stretch or compression, and it affects the period of the function. So to find the new period, we take 2 pi, which is the period of the original function, and divide by our b value. 2 pi divided by 2 is pi, so that will be the period of our transformation. D is a vertical shift. If we're adding or subtracting anything to the end of the function, in this case we are not, so we do not have a vertical shift. Because a coordinate plane has 4 quadrants, the period is broken into 4 pieces. So what I do when I'm graphing a sine or cosine function is I split the x-axis into 4 sections to the left and right of the y-axis. The full period will be the 4th section, and then you cut it into fourths to get the rest of the scale. Pi divided by 4 would be pi over 4, and then we would have 2 pi over 4, or pi over 2, and 3 pi over 4. We'll take those values and reflect them off to the left, giving us negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Our amplitude is 3, which means our graph will go up to 3 on the y-axis and down to negative 3. Finally, we'll put the graph all together. Sine starts at 0, and then it goes up to its maximum, back to 0, down to its minimum, back to 0. Off to the left, it does the opposite. It goes down to its minimum first, back to 0, up to its maximum, and back to 0. So we just sketched 2 full periods for our sine function, one off to the right and one off to the left. Domain for the sine function is all real numbers. No matter what you do to transform your sine function, the domain will not change. The range changes based on any vertical stretches and shifts. In this case, we just had a stretch, so our range is from -3 to 3. We have another sine function. Our a value is -1, which means our amplitude is still 1, but we have a vertical reflection, so we're going to have to be careful. That changes how we'll graph our function. Our b is what we're multiplying by the x, which is 4. So to get the period of our new function, we take 2 pi, the period of sine, divided by 4. Simplifying that, we get a period of pi over 2. D is any value that we're adding or subtracting to the function. In this case, we have a d value of 1, which is shifting our graph up 1. Scaling our x-axis, we will take the period of pi over 2, put that out at the furthest scale. Dividing pi over 2 by 4 is the same as multiplying by 4 in the denominator. So we're scaling by pi over 8 on this one. Pi over 8, 2 pi over 8 simplifies to pi over 4. 3 pi over 8, and 4 pi over 8 simplifies to pi over 2. Reflecting those off to the left. Our amplitude is 1, but we also had a vertical shift of 1. So we're going to need to go up to 2 on our y-axis. One last thing you may want to do before you start sketching this one. Anytime you have a vertical shift, you have a new, it's called principal axis. This is kind of the zeros or the x-intercept of your function. It is not an asymptote. Our graph will cross this, but it's where we will land when we talk about sine being 0. And sine starts at 0, so we're going to start along that principal axis, We have a vertical reflection. Sine typically goes up 1. Now we're going to go down to the minimum, back to 0, up to the maximum, and back to 0. We'll do the opposite off to the left, up to the maximum, back to 0, down to the minimum, and back to 0. Again, domain for our sine function, always all real numbers. The range, as we can see from the graph with that shift up 1, this time our minimum value is 0 and our maximum value is 2. Taking a look at our cosine function, our a value is -1, which means our amplitude is 1. This time we have a b value that is 1/4. So to get the period of our cosine function, we're going to take 2 pi and divide it by 1/4. Remember, dividing by fractions means multiplying by the reciprocal. So the period of our function is 8 pi. We have no d value, so we have no vertical shift. Scaling our x-axis, we will take that period of 8 pi and divide it by 4. So that gives us 2 pi, 4 pi, and 6 pi for our scales. Reflecting that over off to the left, we get -2 pi, -4 pi, -6 pi, and -8 pi. Our amplitude is 1, and we have no vertical shifts. So the scale on our y-axis will be 1 and -1. Graphing our cosine function typically starts at its maximum value. With our vertical reflection, our cosine will start at the minimum value, back to 0, maximum, back to 0, minimum off to the right. And it will do the exact same thing off to the left, up to the 0, maximum, back to 0, back to minimum. The domain for our cosine function, same as sine, all real numbers. The range for this one is the same as the parent function. We had a reflection, but no stretching or shifts. One last graph. This time our a value is 1/3, which is the same as our amplitude. Our b value, what we're multiplying by the x, is pi. So our period will be 2 pi divided by pi, or 2. Our d value, our vertical shift, is down 2. Scaling our x-axis, we will go out to 2. 2 divided by 4 simplifies to 1/2. 1, 3/2, or 1.5 if you prefer, and reflecting off to the left. We have a shift down 2, but our amplitude is only 1/3. So as we're sketching our graph, we will have to be very careful thinking about where that lands. Once again, I'm going to sketch in that principal axis, or where we're going to land when we're at the 0 part for our cosine function. We had a shift down 2, so that's our new principal axis. Cosine starts at its maximum, so I'm going to go up 1/3, back to 0, down 1/3, back to 0, up 1/3. Doing the exact same thing off to the left, down to 0, down 1/3, back to 0, up 1/3. Domain, of course, is all real numbers. Range. We are 1/3 below -2, so we're at -2 and 1/3. And then we are 1/3 above -2, which is -1 and 2/3. No you try today, as these are quite involved, so we'll pick a problem or two from our assignment to start us off together. Please make sure you make notes of what's most challenging so I know where to start class.